Panda, 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 panda. I got broads in Atlanta, just to lean the family. Credit cards in the scammers, hitting the licks in the van.
Hello, awesome students. Welcome to Learn Maths with Teacher Dennis. Are you ready for our next lesson? Our lesson for today is all about the real number system. Real numbers are composed of rational numbers and irrational numbers. Rational numbers are made up of non-integers and integers. Non-integers are terminating decimal and repeating decimal. Integers, on the other hand, have negative numbers, zero, and natural numbers. Zero and natural numbers are also called whole numbers. Real numbers. Okay, so as we know, it is consist of rational and irrational numbers. If the numbers are not real, they might be like complex numbers or like they are imaginary numbers. Rational numbers. Rational numbers are any numbers that can be expressed in the form m over n, or it can be expressed in a ratio form, where m and n are integers and n is not equal to 0. Okay, so as you can remember, real numbers are composed of rational numbers and irrational numbers. So if n is equal to 0, it can be an imaginary number. Okay, let's say 1.5. So in fractional form, it is 3 over 2. So if you can see, it can be expressed into a ratio. Let's say negative 5. So in a fractional form, we can write it as negative 5 over 1. So it also can be expressed in a ratio. So rational numbers, we have, it can be a 1.5 or negative 5. So these are actually examples of a rational number. Again, rational numbers are composed of integers and non-integers. Okay, non-integers and integers. Okay, so let's first talk about integers. So you have learned this, I think, for the past maybe how many years now? So that integers are made up of negative numbers, 0, and natural numbers. So here, so I've always told you that an integer is composed of negative number 0 and also a positive number. And 0 and positive numbers are what we call also whole numbers. Other terms for positive numbers, you can call them as natural numbers, meaning these are the natural numbers that we used on our day-to-day lives, like counting numbers. They use when we count 1, 2, 3, 4, and so on. So positive numbers, it's also refers to a natural number or a counting number. So again, so these are in such form negative numbers of negative 1, negative 2, negative 3, and so on. 0. Yes. Positive counting and natural numbers, they refers to a similar thing, which is the positive numbers. You have 1, 2, 3, 4, and so on. And we have the whole numbers. Whole numbers is just 0, and all the positive numbers here. So please remember that integers are made up of negative numbers, 0, and positive counting natural numbers. Non-integers. Okay, so if we go back, rational numbers are made up of non-integers and integers. So non-integers, we have first terminating decimal. So what is the terminating decimal? So terminating decimal, it means like a decimal that it ends. So it has an ending. It stops. Okay, so other terms. So we have 1.75. So this is the whole term. So it doesn't extend. It stops at 0.75. It terminates. So let's say the fraction 3/2. So in decimal form, it is 1.5, right? So it stops there, 1.5. It terminates there. Let's say this number 2.65476. It stops at 6 here. It terminates at 6 here. So it's what we call the terminating decimal. 11/4. So this is a fractional form, but in decimal form it is 2.75. So it stops here at 5. That is what we call terminating decimals. It falls under the non-integers. Okay, the second one is repeating decimal. So as from the root word repeat. Okay, so these are the decimals that repeats. Okay, so if you can see here, 1.675675. Okay, so different books shows different representations here. So some you can see dots. So that means that these three numbers here repeats infinitely. So it will just repeat itself. 675, 675, 675, and so on. Let's say the fraction 5/3. In decimal form, it is 1.6666, and so on. So if you cannot see the dots, sometimes it is there's a bar on top of the repeating number. So in this case, 6 or 66. So that is the repeating number. So it will be 1.6666 and so on. 2/7. In the decimal form, it is 0.28574. Actually, it's 4. There's a 4 here. So it repeats this set of numbers: 287, 285714, and so on. So again, non-integers are made up of terminating decimals, that are decimals that stops, and also repeating decimals, the decimal points, or the decimal values that repeats itself. Okay, so we already talked about this side, right? So rational numbers. Again, rational numbers, we have non-integers, terminating decimals, repeating decimals, integers, -0, and natural numbers. Now we go on to irrational numbers. So what are the differences of a rational number and irrational numbers? So irrational numbers are non-terminating and non-repeating decimal. See, if you can see here, rational numbers, they have terminating and repeating decimals. Irrational, they are non-terminating. It never stops and it never repeats the decimal values. Okay, so let's say the pi. Okay, the pi value is 3.14514159264. The values never repeats and it will never terminate. So it continues infinitely Okay, it continues infinitely without any repetitions or without any patterns of repetitions of numbers. Let's say square root of 2. So it's 1.414213562. It never repeats, it never terminates. Usually, class, the root of not perfect square is usually in an irrational number. So if you square root a non-perfect square number, it is usually irrational number. Let's say square root of 5, square root of 7, square root of 10. So they are irrational numbers. They are not perfect square. Okay, let's say if you can see this number 4.682, so it doesn't have any bars or any points on the top. That indicates that the number or the decimal values repeats itself. It will fall under irrational number. So if you can see, there are 3 dots here. So these are called ellipses, which signifies that the numbers continue infinitely through infinity. Okay, so I have here a diagram of a real number system. So let's try to put on the numbers here. So I have 5. So 5 will be under where can we put 5 here? Positive 5. So we can put it here because it is inside a natural number. It is inside the whole number. It is also falls into integers and a rational number. How about negative 5? Can it be natural? No. Can it be whole? No. But it can be an integer. It falls into integer. It falls into a rational number. It is a rational number. It is an integer. How about 0? Okay, 0 will fall into whole numbers. Yeah, it is a whole number. It is an integer. It is a rational. 0.25. Where can we put 0.25? Okay, you're right. So we are right. It is not integer. It is not whole. It is not natural, but it is a rational number. The pi. Okay, pi value. Okay, so we have it falls into a irrational numbers. Okay, is that clear? So once again, this is the real number system. Thank you for listening.